Okay, so here we are. We've finally gotten to the last section of Chapter 1, which means after we finish this, we'll be ready for a Chapter 1 test. I do think we'll probably just do a short quiz on 1-6. So what we're moving to now, again, like I said, Chapter 1 has such a mixed bag of a lot of things. So we're going to put together two of the biggest concepts we've studied so far, which would be segments and angles. And what we have in any kind of polygon, which is a closed figure with a fixed number of sides. So if we're putting those two pieces together, if a quadrilateral, or a polygon has all sides congruent, all sides are equal in length, that's called an equilateral polygon. If all the angles are equal, we would say that that's a equiangular polygon. So a little bit new terminology here. And then also, like Mr. Blaylock talked about, concave or versus convex. An easy way to picture it is if something is concave, it's sort of dented in. Like if I look at a polygon, you can almost tell when you see it that it's concave. But the technical term just means that if I extended the sides of any one side, if they somehow extend into the interior of the polygon, like we have here and here, if I do that with any of the sides over here, oops, no, that was kind of a sloppy extended segment, but none of those sides are going to intersect inside here. None of them are going in there, but if a polygon is concave, if it's caving in, if it's dented in, then we will have portions of those sides that will go inside the polygon. Okay, so we're going to do two things with these, and we want to answer two things. We want to name the polygon by its side, and then we want to talk about whether it's convex or concave, and whether or not it's regular or irregular. Okay, so I'll look at a couple with you, and then I'll let you finish the rest of them on your own. So the very first one here, number 1, we look at this polygon. First of all, we wouldn't have any sides. There's no dent in it that would make it concave, so it's going to be convex. Actually, let's do number of sides first. I'm going to count up the number of sides I have here. I have 1, 2, 3, 4, 5, 6. So that is going to be a hexagon. We have 6 sides. That's a hexagon. Okay, it is going to be convex, like we said. It's not caved in anywhere. And because every single angle and every single side are equal to each other, we call that a regular polygon. Okay, and the next one, let's take a look. Okay, number 2, when we have 4 sides, we call this a quadrilateral. Right? When we have only a few sides, like 3 or 4, we don't start to add the gons on the end of it, like pentagon, hexagon, octagon, decagon, and so on. We have 3 sides is a triangle, 4 sides quadrilateral. So they commit that to memory. Now it's not dented in anywhere, so this is going to be okay to be convex for us. Right? None of those sides are going to have an intersection inside the polygon or move into it. Now we do have all 4 sides equal, but we can see this looks like an acute angle. And this one over here is obtuse, right? So all 4 angles are not equal. We do have all 4 sides equal, but not all 4 angles, so we're going to have to classify that as irregular. Right? And then finally, number 3, what's happening here? Number of sides, we have 1, 2, 3, 4, 5. 5 sides is a pentagon. Okay, now what's happening here? If I extend this side, it extends inside in the interior of the polygon, so we know that this is concave. It's sort of dented in. Right? Now I have 3 sides equal. The other 2 sides are not marked as equal, and I don't have any angles marked as equal, so we're going to have to classify that as irregular based on what they're telling us. So next, in the Edpuzzle, tell me about number 4. All 3 situations here. So hopefully you classified this as a triangle. It has 3 sides. Then you're able to say that this is convex. It's not caved in any way. None of the sides or angles are marked, so we're going to have to label that as an irregular. Call that a scalene triangle. Okay, how about number 5? Okay, so hopefully we counted up the sides and found 1, 2, 3, 4, 5 sides. It's another pentagon. Okay, we do have concavity here. It's caved in, so it's going to be concave. And then the last part here, again, we have another irregular polygon. Okay, and lastly, let's try number 6. So first thing we ought to do here is count up the sides. I'm going to erase that circle there so we're not confused by anything. We have 1, 2, 3, 4, 5, 6, 7, 8. Very weird looking octagon, but it is indeed an octagon classified by the sides. It's certainly concave because see how these sides would extend inside? It's dented. It's like a little Pac-Man situation happening there. And then finally, this is also irregular. We don't have any information about the sides. So we're going to focus on a few specific polygons, and in fact, a circle would be like a polygon with infinitely many sides. A regular polygon becomes a circle, so we'll talk about that in a second. But we want to focus on a couple things with each of them. Their perimeter, or in a circle, we call that the circumference. It's the distance around it. So we need a special formula for that for a circle. And then the area, right? So two pretty practical applications of geometry that you see here. Perimeter, if you wanted to build a fence around a certain amount of land, that would be a perimeter situation. If you wanted to carpet or paint, that's an area situation. So very practical to be able to count these. So for the circle, we want to make sure we differentiate between these two really famous formulas. The circumference, it's just the distance around, that's 2 pi times the radius. The area, if you think about what's happening with area, it's all these little squares. Right? That's what we mean by area. We break up the area into squares, and we basically literally count how many squares there would be there if we could. So that's an easy way to remember that. The r squared is in the area formula. For a rectangle, the perimeter, we just add up the 4 sides. We have 2 lengths, we have 2 widths, we add them up. For the area, we just multiply length times width. Every triangle is half of a rectangle. So in this case, we just take 1/2, basically the length times the width. We call them the base and the height, but we just take 1/2 of that, and that will give us our area. And the perimeter, just like in a rectangle, we just add up all the sides. In the case of a triangle, it's only 3 sides. Okay, so let's take a look at what this looks like. Our perimeter here in the first one is just going to be the sum of the 3 sides. Just going to add them up. 2.5 plus 3 plus 3.5. That's my total perimeter. And we get 9 centimeters. The area is 1/2 the base times the height. And you can see my base and height have to be perpendicular. So those would have to be the 2 numbers that I'm going to use. 3.5 times 2. That's my base times my height. I have to find the 2 segments that are perpendicular to each other, not necessarily sides. So we multiply that out. We're going to get 3.5. And then notice the difference here. It's centimeters squared, or squared centimeters. Okay. For my circle, I'm not going to call it perimeter, I'm going to call it the circumference. And it's 2 pi times the radius. So we could just say 8 pi feet. But my directions do tell me to round to the nearest tenth. So if I just grab my calculator real quick and we type in 8 pi, it doesn't look like I have a pi key on this particular calculator, so I'll use 3.14, see if I get about the same answer. Yeah, so to 1 decimal place I get 25.1, and that's what I got on my graphing calculator. Okay, 25.1 feet. And then for area, what do we have? This is going to be pi times the radius squared, which would be 16 pi. Or again, if we want to use our calculator for that, 16 times 3.14. Round to the nearest tenth, that would be 50.2 square feet. I'm going to put a little squared symbol on it. Okay, so next to, we don't have any circles here, so tell me the perimeter and the area for each of these. Okay, let's answer each of those in the Edpuzzle. Okay, so for my perimeter here, hopefully we said that this was 14 plus 14 plus 14 plus 14, 56 yards. And then for the, we have 14 times 14, which would be 196 square yards, or yards squared. All right, so 14 plus 14 plus 14 plus 14. That's where I got my 56. We add all 4 sides up. They're all congruent. They're all 14. Okay. How about the next one? What do we get here? So for perimeter, we just take 3 plus 5, which is 8, plus another 4. That would just be 12 centimeters. And then the area would be 1/2 the base, which is 4, times the height, which is 3. So that would give me 6 centimeters squared. Okay, and then finally, the last thing we want to do here is graph these figures in the coordinate plane and identify them, and also calculate the perimeter and the area of each one. So I'm going to plot the 4 points first. So hopefully we just at least came up with the fact that what we have here is a triangle. I'm going to skip the perimeter and area part for this one. What we need for perimeter and area is the lengths of the sides, and we have to use the distance formula to find that. So we'll skip that part for the perimeter and the area of the triangle here, and move on to the next one. But hopefully we are able to identify that as just a triangle. So let's try the next one here. Tell me what kind of figure it is, and then the perimeter and the area. Okay, so those are the 4 points I have. What kind of figure are we looking at here? So hopefully you're able to picture, if I drew the lines in here and connected sides, we do have a quadrilateral, but more specifically, this is a rectangle. So if you say quadrilateral or rectangle, either one of those is okay. But since the opposite sides are equal 90 degrees, we have a rectangle, which is going to make the perimeter and area pretty easy to find. So for the perimeter and for the area, we're going to need the lengths of the sides. So let's just count. If we go to XZ, 1, 2, 3, 4, 5, 6, 7, which means this is 7. 1, 2, 3, 4. Okay, so we have a rectangle that is sides of length 4 and 7. Tell me the perimeter and tell me the area. Okay, so hopefully for perimeter, we just added 4 plus 7 plus 4 plus 7 and got 22. Okay, so it's 22 units. We don't really have centimeters or inches here. They're just our graphing blocks. And then for the area, we're going to multiply. 4 times 7 equals 28, and that's square units. I don't know what the units are, but if we went in here and counted up all these blocks, 1, 2, 3, count so you can see 2, 3, 4, so you see what I'm doing, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 square units. That's why our area is 28. It's literally all the blocks in there.